Everyone, we'll try to discuss one more problem on the psychometric properties. So in this particular problem, he is stating that atmospheric air is at 750 mm of Hg. So the pressure of the atmospheric air is been given in the different unit here. So he says it is 750 mm of Hg. How to convert this? So the total pressure, which is atmospheric air, which is given as 750 mm of Hg. So you know that the barometric pressure can be converted into a manometric pressure using a relation rho g h. Rho is density of whatever manometric fluid you are using. In this case, it is Hg. So density of the Hg, which is mercury, is 13,600. G is your 9.81, and h is the height of that manometric liquid in meters. So here it is 75 mm, is it? So you need to convert into meters, so it is 10 to the power of minus 3. So when you calculate all this, it comes around the PT value as 1.0062 bar. So this is the change which is observed. So 750 mm of Hg is the atmospheric pressure, which is given in a different unit. You need to convert using the formula rho gh. Rho is the density of the manometric fluid, g is the acceleration due to gravity, which is 9.81, and h is the height of the manometric fluid. Okay, so that has been given. dBT is given as 34 degrees Celsius, and WBT is given as 24 degrees Celsius. So he has given both the temperatures. He has given the dBT also, and he has given the WBT also. So he is asking us to calculate what is relative humidity. Humidity ratio is nothing but your specific humidity, dew point temperature, enthalpy of atmospheric air, density of our moisture, and degree of saturation. So all these parameters you need to calculate here. So let us go in depth in it. Okay, we shall calculate one by one. Now, so first thing asked is the relative humidity. So relative humidity is given by PV divided by PVS in WBT. Correct. So you don't know the value of even PV also. You know the value of PT. So PV see, when in the problem he has given both the values of dBT and WBT. So when in the problem he has given both the values of dBT and WBT, you need to use this particular formula to calculate the value of PV. Okay. So in the problem, if he has given the value of WBT and dBT, you have to use this particular formula to calculate what is PV. Okay, so PV is given as PVS, saturated vapor pressure at WBT. So look this at carefully. This is at WBT. So PVS at WBT minus PT minus PVS at WBT again into dry bulb temperature minus wet bulb temperature into 1.8 divided by 2800 minus 1.3 into 1.8 into dry bulb temperature plus 32. So remember, you have to remember this particular formula, which will be helpful in calculating the vapor pressure when WBT and dBTs are given. Okay. So you know the values. So first you have to calculate the value of PVC at WBT. So what is the WBT? It is 24 degrees Celsius. Check in the steam table. The 24 degrees Celsius will not get the exact value. You get the value for 20, you get the value of 25. For 20 it is 0.023366, and for 25 it is 0.031660. So your 24 degrees Celsius comes in between these two values, is it? So it comes in between these two values. So use the interpolation method of finding the things. So this becomes your x1 value, and this becomes your x2, and this becomes your y1, and this becomes your y2. So this is the x at which you need to calculate what is y. So x1 is 20, for which y1 is 0.02366 from steam tables, x2 is 25, for which y2 is 0.03166, and your intermediate temperature is 24 degrees Celsius, for which you have to calculate what is y value. Okay. Now, so y is given by, remember this formula again, which is very important, y1 plus x into x minus x1 divided by x2 minus x1 into y2 minus y1. Substitute all the things, you will calculate what is PVS at WBT, which is given as 0.03 bar once you calculate the things. Next, so once you know what is the value of PVC at WBT, you have calculated just now. You know the value of PT as 1.0062, the converted value, and the dry bulb temperature no, and wet bulb temperature no. Substitute all the things in this particular equation. Your calculated value would be this much. So it is 0.02635, which is the pressure of vapor. So you have calculated what is the vapor pressure in the previous step. So now you need to calculate what is the saturated vapor pressure at DBT in the sense it is dry bulb temperature at 34 degrees centigrade. Again, you have to look into the steam tables. Your 34 degrees Celsius will lie in between 30 and 35. For 30 it is so much, and for 35 it is so much. Again, use the same method of interpolation. You will get the PVS of at WBT as 0.05345 bar. So once you have calculated the value of PV and PVS at WBT, so just substitute the things and your relative humidity would be 49.3%. Okay, that is how you calculate the things. Okay, next, humidity ratio. So you know the value of PV, you know the value of PT, substitute all the things since PA can be calculated as PT minus PV, is it? So substitute all the things, you will get the value of the specific humidity as 0.0167 kg per kg of dry air. Okay. Next. So dew point temperature. For dew point temperature, as I told you in the previous video, dew point temperature always corresponds to the vapor pressure. So dew point temperature always corresponds to the vapor pressure. That means you have to look for the pressure of vapor, which is 0.02635 bar, and measure the corresponding temperature of it, for which you will use the steam tables for it. If you go, so you will note down the pressure basis steam table, for which it is 0.02 value is 17.51 temperature, and for 0.03 it is 24.1 temperature. So your value of 0.02635 comes in between 0.2 and 0.3. Again, use the same interpolation method of calculating the things. So use this particular formula, you substitute the things, you will get the value of dPT as 29.67 degrees centigrade. Okay. Now, enthalpy of moisture. For enthalpy of moisture, you have this particular formula which is given to you while explaining the psychometric properties, which says enthalpy, specific enthalpy is given as 1.005 TdB plus omega, which is specific humidity, into 2500 plus 1.8 again TdB. So you know the value of TdB, you know the value of specific humidity, substitute the things and calculate the enthalpy of moisture as 76.94 kilojoules per kg of dry air. Okay. Next, density of the moisture. So density of the moisture, in the sense it is the summation of density of the dry air and density of the water vapor, is it? So density, calculate the density of the air separately and calculate the density of the moist air separately using the ideal gas equation. Just substitute the things, it is a common substitution. You will calculate the density of air as such much and density of vapor as this much. So add these two to get the values of the total density of the moist air as 1.313 kg per meter cube. Okay. So you can, your next thing is degree of saturation, which is indicated as mu here. So this is indicated as mu. This has a specific formula which is given in the property table. So mu is equals to 5 into Pt minus PVCS at WBT. Remember, so the saturated pressure is taken at WBT divided by Pt minus PV. You know the value of relative humidity, you know the value of Pt. PVS at WBT you have calculated previously. You know the value of PV, substitute, and you will get your the degree of saturation, the value of mu as 0.476. Okay. So similar problem we can try from this particular thing, which is asked in Jan 2015. Okay, but it was similar problem. So dBT is given here, WBT is given. So all the things which you have calculated has been asked for 11 mark, guys. So just try this particular problem. And any doubts, you can contact me.